Hello everyone and welcome to the aTech channel. Today we're going to look at the growing demand for electricity globally. If people are switching to heat pumps, natural gas, or electric cars, the demand will only increase. That's why the demand is exceptional. We often talk about solar energy, but the world's production of wind energy is about twice of that of solar energy. According to data from 19 studies, offshore wind energy alone could power the entire world. However, this energy source has many shortcomings, but today, thanks to new technology combinations, hydraulic wind energy could provide an innovative and revolutionary solution. Before we get into the heart of the matter, we invite you to subscribe to the channel and activate notifications so as not to miss any of our next videos. Let's get started. Western countries are building offshore wind farms as fast as they can. Why aren't there any anywhere then? When you think of wind turbines, you probably picture something like massive horizontal axis wind turbines, but a company called Hydro has developed a solution to process offshore wind problems, using vertical axis wind turbines with some very interesting properties. It is estimated that 80% of the world's wind resources are available offshore, not on land. The question is how to harness this source and transform it into a usable form of energy. Our approaches are to use wind only for mechanical lift. But before we get into that, let's talk about the conventional offshore wind turbines. Wind speed data for existing installations have shown more variable and intermittent wind speeds. The highest wind speeds are in the winter, which is good news. That's when the solar energy is at its lowest. Before you think that the wind speeds are super consistent through the day, remember, this is an average. That's the first major problem with offshore wind. It's unpredictable and varies through the day. There's no way to increase or decrease production to match what people are using. German wind giant Seisma is preparing to deploy 60 state-of-the-art turbines by 2024. Each of these 60 wind turbines produces 14.7 megawatts, which is a world record. They will have a 108-meter long center, the size of a soccer field. The rotation diameter is 222 meters, or about 45 Tesla Model S cars parked side by side. Such measurements make it pretty impressive technology. There are problems, however, as the cost increases dramatically as the size of the blades increases. Both because of the size of the molds and the castings needed to create the blades, but also because of the logistics involved in building a larger support towers. With offshore wind, anchoring is done safely in the shallows using monopods. A monopod is a steel cylinder driven into the seabed by a special hydraulic arm. Offshore wind turbines continue to grow larger and larger, which creates many problems. They are largely limited to the height of about 50 meters, which will reduce the places where you can be installed. The second problem with offshore wind turbines is that they're not really able to exploit the full potential of high winds. They need an airspeed of about 5 meters per second to start spinning and must stop when the wind speed reaches about 25 meters per second. Their ideal operating range is about 10 to 15 meters per second. More modern turbines such as the Siemens Gensma 14.7 megawatt turbines use technology called high wind. These turbines have an effect of a laminar flow of air, impacting other turbines in the process. Faced with this complex issue, NVIDIA, a company that uses AI and computer simulation to determine the optical location of wind turbines, but not only that, it helps to optimize the trajectory of the wind that has exited the turbine, both on the individual scale and a single turbine as well as a wind farm. Thus, they should be installed optimally at a distance of 3 kilometers. These large distances mean that the production density is reduced, but also that the maintenance times would be higher, not to mention all the wiring and connections between them. As wind turbines get larger, the cost per megawatt production continues to drop. This makes them more cost competitive. In contrast, hydroelectric wind power would solve this problem. But what about vertical axis turbines? The Ocean Hydro Omni operates in the ocean on the basis of hydro wind. Its efficiency is equivalent to that of a conventional wind turbine with hurricane winds. Thanks to this process, it further optimizes wind resource, allowing an efficiency of 50% against 35% usually. Its particularity is not to use the wind in a traditional way, but rather to lift a heavy mass. Then, when energy is needed, the weight can be released, generating power. The Ocean Hydro Omni can operate in a much wider range of wind speeds because they do not have delicate electronics and generators attached to the turbines. In addition, unlike traditional wind turbines, the Ocean Hydro Omni can meet grid needs by soaring or releasing energy on demand. If winds are strong and demand is low, they can lift weights and stand up. When demand increases, they can release the weights at a given speed and create a uniform energy output. By lifting them, we absorb the variability of wind power, allowing energy to be produced on demand. Wind and solar can provide energy on demand. One of these things that is problematic in renewable energy future is energy storage. The first Ocean Hydro Omni plot installation is scheduled to be in late 2022 and will be installed at the depth of 300 meters. So it's not just a hydro wind energy generator, it is also a battery and a smart grid device. That's the strength of this technology. A single Ocean Hydro Omni will probably not be able to produce as much energy as traditional wind turbines, but because they can be grouped closer together, the cost per turbine will be more cost effective than traditional wind farms. Build enough turbines and it will be possible to meet the demand of an entire grid. It's not the use of vertical axis and gravity batteries that make it an interesting technology, it's the combination of these different technologies together. But wind hydropower is not yet developed. Where are they in development process? A prototype has been tested with all these systems, including components and subcomponents, but eventually the next step is to finalize the subsystem and test it in the real offshore environment to move the technology readiness level. If they're successful in their strategy, they will have similar vertical turbines that can be built closer together in deeper water, with integrated energy storage. The advantage of the Ocean Hydro Omni makes it preferred solution in a renewable energy race. This is mainly due to the production capacity and greater flexibility. If we want to move away from fossil fuels, we need to use as many different renewable energy sources as possible. What the Ocean Hydro Omni can provide will be huge, not only to produce energy, but to also reduce storage needs. If you enjoyed our topic of the day, feel free to like this video. To enjoy more videos like this, subscribe to the channel, and most importantly, leave us a little suggestion for future topics. Activate that bell notification to be among the first to see the next videos, and we hope to see you soon on aTech.